Alright, we're good then. Let's go. Graph 2 complete. Periods of function. And this is a cos. Alright, so I'll write down this formula, I guess. Whatever you call it. I think this is the same for a cos. Alright. So the negative in front, that's amplitude, I'm pretty sure. Hold on, I'm pulling up chat. Alright. So that's amplitude. B is 1. C is negative pi over 4. Okay. Okay, so amplitude is just 1. It's the absolute value. It's next. Period. 2 pi over b. So this is 2 pi. Phase shift. Phase shift is c over b. So it's just negative pi over 4. And vertical shift, I think, is just k. Yeah. So 0. Alright, so now I have to graph it. Should I use lines for this, or I'll just make a for the axis. Alright. So period's normal. So I'm just gonna make it 1, 2, 3, 4, 2 pi at the end. Pi over 2 here. Pi and then 3 pi over 2. And then I'll do the negatives. Negative 3 pi over 2 and negative 2 pi. Alright. So the amplitude's normal, so I'm just gonna write 1 and negative 1. Drag this down a little bit. Okay. This is a cos. So I think cos starts at the top. Yeah, it starts at 1. What is cos 90? I think it's 0. Yeah, it's 0. Cos pi is yeah, it's negative 1. And yeah, this should be like this. There's a phase shift though. What do you do with phase shift? Alright. I have to look this up. had a graph case. Alright, I'll do it like this. There. Or maybe up here. Perfect. Alright, Brian, what you got to say? What?
How to graph f of x equals 3 cosine of x plus 2 pi over 3 minus 2. And to go through a problem like this, we need to kind of understand, what are each one of these different numbers, how are they affecting our graph? So to do that, we want to kind of know what the transformations are. So we want to write this out as a times cosine of bx minus c plus d. All right, where you can see we pretty much have every single value except for b. Thank you. So I almost have a full set of transformations, but not exactly, but I still have a full load. The first thing we want to do is determine, our important information, our amplitude, our period, our x scale, our phase shift, and our vertical translations. Okay, so to determine the amplitude, that's simply just taking the absolute value of A. The period is simply going to be 2 pi divided by b. Your x scale is simply your period divided by 4. Phase shift is whatever's inside your parentheses set equal to 0. And your vertical translation is d. Now,
wait, is it actually, you can write it like that? Is that just what I did, or? No, I guess that's another way of writing it.
To go ahead and solve for each one of these, all we're simply going to do is look at our values for a, b, c, and d in our equation and just plug them in. So absolute value of a, absolute value 3 is equal to 3. For period, you have 2 pi divided by b. Well, b in this case is 1, so it's just 2 pi divided by 1, which is just 2 pi. Our period is just going to be 2 pi over 4, which equals pi halves. Our phase shift is going to be set whatever's inside of our parentheses, so x plus, x plus 2 pi over 3 equals 0. X equals negative 2 pi over 3, right? You have to subtract 2 pi over 3 on both sides. And then d is going to equal negative 2. That means I'm going to shift my graph down 2 units. All right, so now that we have an amplitude, we kind of need to understand what exactly is amplitude going to be doing to our graph. All right, let's start at 0 here. And now, when I'm graphing a trigonometric function, a lot of times we start at our initial period.
Wait a minute. It would be positive pi over 4 then, for the phase shift. But not. How do I do it? Period equals, or wait, phase shift, c over b. Positive c over b left, I guess, something else. Okay, so the c is negative, the b is 1. What? Is that really how you do it? Hold on, I need a tutorial for phase shift now. I can just look it up.
And side of our function, which in this case is 2. So we have 2 pi. Now when I go ahead and solve, pi to the right. Now
I'm just going to do it his way, actually. So you set what's inside equal to 0. Yeah, it should be positive. Alright. I guess I'll keep watching then.
Period add 0, right? And we say 0, and you can do 2 periods to the right, 2 periods to the left, period to the right, period to the left. Doesn't really matter. In this case, I'm going to do a period to the left and a period to the right. Now, this is going to go ahead and get fun. Because first of all, we know our amplitude. Remember, amplitude is the half distance from the maximum to the minimum. Pretty much the distance from wherever your graph crosses the x-axis to its maximum or its minimum. So since that is 3, I'm going to go up 3, 1, 2, 3, and down 3, 1, 2, 3. However, I do also notice that I'm going to be shifting the graph down 2 units. So down 2, so I'm going to have to go 1, 2, 3. And I'll show you guys that in just a minute. The main important thing I think is the hardest thing to do right now is to be able to identify the x scale, all right? So we're starting, rather than starting at 0, which is the parent graph we started, we're going to start at negative 2 pi over 3. So let's just say negative 2 pi.
Rosa, would you come to the front office, please? Rosa.
Okay, so we have negative 2 pi over 3. Now, the main important thing for us to understand is, remember, we're going to be doing our x scale, and we need to go to our x scale to the left and to the right in this case, or you can do 2 to the right. But remember, there's 4 x scales in each period. So to find my next scale, let's make it right there. To find my next point, I'm going to have to add, that's going to be over pi halves to the right. So what I need to do is, let's see a little work here. Let's do it over here. So I can simply just take negative 2 pi over 3 plus pi halves. Now obviously I got to get them to be common denominators, right, to add these up together. So I multiply by 2 over 2, 3 over 3, and what I get is...
Alright. Do I wash the rest? I'll watch
negative 4 pi over 6 plus 3 pi over 6, which equals negative pi over 6. So therefore, this next value is negative pi over 6. All right, then I need to add another scale, another scale, and another scale. So I'm going to keep on adding pi halves. So now I just take negative pi halves plus, negative pi over 6 plus pi halves. Again, I need to get common denominator, so I'll multiply by 3 over 3. In this case, I have 2 pi over 6. Now, what I like to do is, rather than simplify each one of these, I like to kind of keep them in the same order so I can say, well, what am I adding from negative pi over 6 to 2 pi over 6? You're pretty much adding 3 units up top. And let's just go and see, is that going to make sense as well going backwards? Because simply that would be negative 4. Yeah. So really this is like negative 4 pi over 6. Now you can keep on doing the algebra if you want to, but I've figured out the pattern of adding it is really just like 5 pi over 6 and 8 pi over 6. Now again, I will go back and simplify them, but again, remember, here's our starting point, right? So I'm going to do a period to the right as well as a period to the left. So I'll do 1, 2, 3, 4. So now, rather than adding, I'm now going to subtract. So negative 7 pi over 6, negative 10 pi over 6, negative 13 pi over 6, and negative 16 pi over 6. And then for each one of these, I'm simply just going to go ahead and reduce. So that's really negative 8 pi over 3. That's negative 5 pi over 3. That's negative 2 pi over 3, which you already did. That is really pi over 3, and that is really 4 pi over 3. All right, so I know that's kind of like, we were like, whoa, way too much information, right? All right, so let's get on the ones that...
So I'm wondering, if you start at negative 2 pi over 3, is that where the cos graph, like, would it start at 1? Or in this case, it's 3. I'm thinking it will.
Oh, shoot. I like that one. Okay, so now I got my scale, and remember, here's where we start, right? Now remember, I said that this graph is going to shift down 2 units. Now, first of all, so if we're going to be shifting down 2 units, what I'm going to simply do is take my x-axis and shift it down 2 units. And I'm going to represent the x-axis with a dashed line, okay? Now, since I have this as a dashed line, we also got to remember, how high are we going up? Remember, the cosine graph at its initial period starts at its maximum, right? Well, the maximum in this case has an amplitude of 3. So from my starting point right here, I'm going to go up 3 units. 1, 2, 3, because that's going to be the highest. Then I need to go down 3 units from this point. These are like swayed in the wrong direction. Okay. Then I need to, so I start here. The next point, which is at negative pi over 6, is going to be my intercept. Then I need to go down 3 units, 1, 2, 3, which is going to be my minimum. Go back to my intercept, and then back up to my max. So therefore my graph is going to look something like this. And you can see that is one complete period, right? Then I can just follow the intercept point, which is at negative pi over 6, is going to be my intercept. Then I need to go down 3 units, 1, 2, 3, which is going to be my minimum. Go back to my intercept, and then back up to my max. So therefore my graph is going to look something like this. And you can see that is one complete period, right? Then I can just follow in the other direction, where the next point would be intercept, minimum.
Very smart, very smart.
Intercept, maximum.
Wow. Beautiful.
And there you go, ladies and gentlemen. That is how you graph 2 complete periods when you have a change in amplitude, phase shift, as...
Alright, sick. Alright, so back to my thing. So the phase shift is positive pi over 4. Somehow. So this actually all gets messed up then. So this would be pi over 4. I think. Well, I'll just do the math. This should be. Wait, I'm not gonna do it in my head. I'll just write it down. So wait, what are we adding? Pull this back up. He adds. I think this adds it to itself. Maybe.
6 plus pi halves. Again, I need to get...
No, he just adds 90. Okay. Three pi over 4. And if I added that again, it would be 5 pi over 4, and then 7 pi over 4. I think. Yeah, because it's in increments of half. Pi half. Alright, we're chilling. So let's change the negatives. Alright, but the period's still 2 pi. So, what do I do about that?
I said that this graph is
Oh wait, no, I'm fine. Wait. Oh, that's why we did pi over 2. Because 4 of those, like 1, 2, 3, 4, and then you get 2 pi. Oh, we're chilling. Easy. Alright, that makes sense. So if this changes, I'd have to add something different, probably. So let's put the dots. Wait, where'd the dot go? Oh yeah. Crap, messed up. Yeah. Alright, this is gonna be terrible, but alright, that's a goofy graph. Does that look like his? Kinda. Yeah, his is a little better. It's fine then. Is that all we had to do? It says graph 2 complete periods, so it's good enough for me. 54. Another cos. So amplitude is 1. Period is, see that equation again. B is in front of X. So 1, I think. Because you can write it like this. So yeah, it's just 1. God, the period's not changing. Probably have to figure out how to do that too. Phase shift is pi over 4. Alright. No, it's not. That's the other one. Phase shift. Is this this is the one where you can just do x minus 3 equals 0. So 3. I'm gonna look that up again, because I wanna make sure I'm doing it right. Yeah, okay. Vertical shift is 0. Okay, so 3 for the phase shift. Kind of odd. If I did it the other way, what would it have been? Would have been see. -3. No, the negative doesn't matter, I'm pretty sure. I think you just look at the 3. So it would be 3. What do I do with a phase shift of 3? Okay. I'll use straight lines again. Because this is like completely normal except for the phase shift of 3. I don't know what I'll do for that. Okay, so you have to add pi over 2. So if I did that, it becomes a 6 over 2 plus pi over 2. 6 pi over 2 or 3 pi. Really, that's how it'd be. Three pi over 1. I'll just make it 6 pi over 2. So I can make it easier. Pi over 2, 7 pi over 2. Plus pi over 2, 8 pi over 2. And then the negatives. Alright, looking good. Wait a minute, I messed this up for the first one, I just realized. I didn't start at the phase shift. Oh, that's annoying. Okay, so I'd start here. I'm gonna draw them in red, actually, so I don't have to erase all of them. So I think it looks more like this. I'm not even gonna bother to connect the dots. Yeah, that looks good. Alright. So for this, it's 3. So we'll start at 3. And what's the emphasis one? So it's drawn in red again. Oh yeah, look at that. Or wait, what is this one? No, this goes below. Goes to -1. I might have made the same mistake on the one up top. I'll have to check again. That's good. Alright. So that should be it, right? Yep, okay. 55. Let's go. So, in the packet, we're moving on to a new concept, I guess. Trig equations. Solve each of the equations for 0 is less than or equal to x is less than 2 pi. Isolate the variable, sketch a reference triangle, find all the solutions within the given domain. Remember to double the domain when solving for a double angle. Use trig identities if needed to rewrite the trig functions. What in the world, dude? What is that? Holy. Isolate the variable. I can isolate the variable. I understood that. So it should look like that. That looks kind of bad though. Is that really what I want to do? I can rewrite this actually. Oh, wait. Ooh, I see something. Oh yeah, I see some. I can rewrite this even more. This would be huge if this works. Holy dude. Okay, so this equals 1 over negative 1 over so the 2 stays down there then. So if I'm not wrong, you should be able to do negative cosecant x over 2. Wait a minute. Did I carry the... why did I carry the x over? No, okay, that's all wrong. Man. Alright, never mind. I can still rewrite this too. And there's nothing you can do with this. Sick. Alright. So I isolated the variable. Sketch a reference triangle. Are you kidding me? Find all the solutions in a given domain. Dude, it's... There's so many of these. I gotta look this up. I have no idea what you do here. This doesn't even sound familiar.
In this video,
You already know we're pulling up organic chemistry tutor. You already know.
we're going to focus on solving trigonometric equations. So let's start with the one that we have on the board. 2 sine x plus cosecant x equals 0. What do we need to do first? So cosecant x is the same as 1 over sine x. It's a reciprocal function. And right now we can't really solve for sine x. What we need to do is multiply both sides by sine.
This
2
isn't gonna
sine
help me. Or wait. Okay, I was a little too hasty actually. Let me watch this. Because I know how to solve these, but it's asking for like reference triangle and all that. And I saw a reference triangle later on, so
we solve for
I'll
sine
let him
x.
cook.
What we need to do is multiply both sides by sine. 2 sine x times sine is 2 sine squared x. 1 over sine times sine, the signs cancel, so we just get 1. And 0 times sine is 0. So this is what we now have. So if we subtract both sides by 1,
Can I do something like that with mine? No, there's no point.
2 sine squared is equal to negative 1. And if we divide by 2, sine squared equal negative half. Now, sine squared...
Wait, that sounds kind of familiar. Is this like the best form to have it in, I wonder? No, I said isolate the variable. Alright, so I keep it like that.
squared cannot... Whenever you square something, it can't equal a negative number. So therefore, there's no solution for this one.
True.
So that's it for that problem.
Wow.
Let's try our next example.
There's no square in mine.
Cosine x minus sine x is equal to 0. So what do you
Oh,
think
that's
we
an
should do
easy
for this
one.
one?
Come on.
Let's add sine x to both sides. If we do so,
That's too
cosine
easy.
is going to equal sine x. And then after that, let's divide both sides by cosine x. So cosine over cosine, that cancels to 1. And sine over
Tan
cosine
x
is
equals
tangent.
1, isn't it?
So therefore, tangent x is equal to 1. So tangent of what angle is equal to 1? To figure that out, you can
Okay, here
type
we
it
go.
in your calculator. Type in inverse tangent of 1. Hopefully, you can also, if you know the unit circle, you can use that to figure this out. The other thing you could do is know your triangles. There's 2 triangles you need to know. The 30, 60, 90 triangle and the 45, 45, 90 triangle. Across the 30 is 1, across the 60 is root 3, across
Wait a
the
minute,
90
let me
is
try and solve this myself. So, tan is sine x over cos x. Or it's a sine over cos. So it's sine is y on the unit circle. Cos is x. So when would it equal 1? For sine, or for tan 0. The y is 0. Okay, so it's not that one. For 90, maybe. Okay, so for 90 degrees, it's 0. I'm gonna write this down. I don't know why I'm thinking out loud. Zero, 1. 1, 0, 1. So the answer is 90, right? If I'm not mistaken.
is 2. So it can't be the 30, 60, 90 triangle. The reason being is, using SOHCAHTOA, tangent is opposite over is,
Oops.
and if we divide opposite over adjacent, we won't get 1 if we use the 30, 60, 90 triangle. If you do 1 over 2, root 3 over 1, because all sides are different, there's no way it's going to cancel to 1. But the 45, 45, 90 triangle, two sides are the same. And the square root of 2 over the square root of 2 can give you 1. So therefore, we know that the reference angle is 45. If you type in inverse tangent of 1 in your calculator, make sure it's in degree mode, you're going to get 45 degrees. Now, once you figure out the reference angle, using the calculator or
Okay, I
those
was in a
common
whole
triangles
nother.
or the unit circle,
What
here's
did
what you
you
need to do. Alright, so we had tangent x is equal to 1. And one of the answers is 45. Because tangent is positive, you need to know that our answer lies in quadrant 1 and 3. We already have the answer for quadrant 1, that's 45. But we also need the answer in quadrant 3.
Okay, I was way off. What's... Is 1090 not equal 1 though? Hold up. No. Wow, I'm in the wrong mood. I still don't know, hold on. What the? What am I, what am I getting? Error? Okay, you can't even, what? I'm just gonna forget everything I said in the last 5 minutes. I'm rewatching. Hold up.
Sure, it's going to 2 root 3 over 1. We won't get, and if it, 90 triangle. Across the 30 is 1.
Oh, wait a minute. Hold on a second. Get rid of all this. So I think I can just do x equals sine, inverse sine, negative half. I think that's what you do. So, whoa, why is the video so good? It's fine. Because he goes from what I had, except with tan. He has tan x equals 1, I have sine x equals negative half. And then he goes crazy and makes that inverse and isolates the variable. Can I get it the other way? I did. X equals negative sine. One. Two sine. Oh wait, hold up. Then I flip this. Man, what? I'm confused. I'll just watch.
1
I'll watch.
across the 60 is root
Maybe you
4.
explained it. I
Infinite
missed
of
it.
what angle is equal to 1? To figure that out, you can type it in your calculator. Type in inverse tangent of 1. 1, and sine of a cosine is tangent. So therefore, tangent x is equal to 1. So tangent of what angle is equal to 1? To figure that out, you can type it in your calculator. Type in inverse tangent of 1. Hopefully, you can also, if you know the unit circle, you can use that to figure this out. The other thing you could do is,
I gotta watch a video on inverse trig identities.
Professor Dave again. Let's talk about inverse trig functions.
He knows a lot about all kinds of stuff. Professor Dave explains.
We know about the 6 trigonometric functions, and we know about inverse functions. So it's time to learn about inverse trigonometric functions. Let's recall that when trying to find the inverse of a function, like f of x equals root x, we change this into a y, and then we make x and y swap places. Then we solve for y. In this case, that would involve squaring both sides, which gives us y equals x squared. Essentially, inverse functions sequentially undo anything operating on x in the original function.
Wait,
Now let's
hold
try
up.
y equals sine x. If we swap the variables, actually inverting both sides, which gives us y equals x squared. Essentially, inverse functions sequentially undo anything operating on x in the original function. Now let's try y equals sine x. If we swap the variables, how do we solve for y? The only way to do this is to take the inverse sine of both sides. This will cancel out the sine operating on y, and we get y equals inverse sine x. We must note that inverse sine x is not the same thing as 1 over sine x. If we had the quantity sine x to the negative 1 power, that would equal 1 over sine x, which we already know is cosecant x. Would equal 1 over sine x, which we already know is cosecant x. Instead, when we have the negative 1 here, it's the inverse sine function. And rather than sine x, where you plug in an angle and get a sine value, for inverse sine x, you plug in a valid sine value, and it gives you the angle that generates it.
Wait, hold up, buddy. Hold up.
It's the inverse sine function. And rather than sine x, where you plug in an angle and get a sine value, for inverse sine x, you plug in a valid sine value, and it gives you the angle that generates it. Inverse sine can also be represented this way, as arcsine x. We should quickly note that in order for a function to have an inverse function, inverse sine
They flip. Without flipping.
can also be represented this way, as arcsine x. We should quickly note that in order for a function to have an inverse function, it must pass the horizontal line test, because when we find the inverse, we are reflecting the function across the line y equals x, and whatever we get must pass the vertical line test to be considered a function.
Doesn't really help me with anything, but
So sine x as a whole does not have an inverse function, but we will instead look at a restricted domain for this function, from negative half pi to half pi. This section does pass the horizontal line test, and it is the inverse of this section that gives us the inverse sine function, which will look like this. The domain of this function will be -1 to 1, because those are the only sine values.
Okay, I think I kind of get it. So, go back to this. So right now, this is a sine value that gives you this. But if you flip-flop, no, I don't get it. Never mind. Nope.
That are possible. The range will be -½ pi to ½ pi, because those are the angles we get when we plug in each possible unique sine value. So let's make sure we know how to evaluate these. What is the inverse sine of √2/2? Well, if we recall our unit circle, the angle that gives a sine of √2/2 is ¼ pi.
So it's gonna be like the other way. It's gonna be like this side over here, I think.
The inverse sine of √2/2 is ¼ pi.
Wait, what?
Now of √2/2. Well, if we recall our unit circle, the angle that gives a sine of √2/2 is ¼ pi. So the inverse sine of √2/2 is
Hold
¼
on,
pi. Well, if value each
what is that,
unit
dude?
circle, the angle that gives a sine of √2/2 is ¼ pi. So the inverse sine of so let's make sure we know how to evaluate these. What is the inverse sine of √2/2? Well, if we recall our unit circle, the angle that gives a sine of √2/2 is ¼ pi.
Oh, okay.
So the inverse sine of √2/2 is ¼ pi. Now let's move on to inverse cosine. This will be the inverse of cosine x from 0 to pi. This is a different restriction than we had for sine, because sine goes from -1 to +1 as it moves through quadrants 4 and 1. Cosine spans all the possible values from 1 to -1 as it goes through quadrants 1 and 2. So we take the graph of cosine x from 0 to pi and we reflect it across the line y equals x to get the inverse cosine function. As we would expect, the domain is -1 to 1 and the range is 0 to pi. What is the inverse cosine of -1/2? Well, that would be the angle in this interval that gives a cosine value of -1/2. And if we remember the unit circle, we know that must be 2/3 pi. Now let's look at inverse tangent. Starting with tangent x, we see that we will want to restrict things to within -½ pi and ½ pi, so that it passes.
Know your triangles. There's two triangles you need to know. The 30-60-90 triangle and the 45-45-90 triangle. Across the 30 is 1, across the 60 is √3, across the 90 is 2. So it can't be the 30-60-90 triangle. The reason being is, using SOHCAHTOA, tangent is opposite over adjacent. And if we divide opposite over adjacent, we won't get 1 if we use the 30-60-90 triangle. If you do 1/2, √3/1, because all sides are different, there's no way it's going to cancel to 1. But the 45-45-90 triangle, two sides are the same. And the square root of 2 over the square root of 2 can give you 1. So therefore, we know that the reference angle is 45. If you type in inverse tangent of 1 in your calculator, make sure it's in degree mode, you're going to get 45 degrees. Now, once you figure out the reference angle using the calculator or those common triangles or the unit circle, here's what you need to do. Alright, so we had tangent x is equal to 1, and one of the answers is 45. Because tangent is positive, you need to know that our answer lies in quadrant 1 and 3. We already have the answer for quadrant 1, that's 45, but we also need the answer in quadrant 3. So to figure this out, we need to find the angle from here to here. This is 180 plus 45. So 180 plus 45, the other answer is 225. Now that's the answer in the range of 0 to 360. If it's from 0 to 2 pi, if you get a question like that, typically they want the answer in radians. So if we convert degrees to radians, multiply it by pi over 180. If you divide it backwards, 180 divided by 45 is 4. So this becomes pi over 4. And 225 is 5 times the value of 45. So 225 is 5 pi over 4. So those are our answers in radians. Now sometimes you may have to find an equation that describes all of the solutions. Typically, in a problem like that, you won't see this restriction. Now what you could do is say you can add 2 pi n to each of your answers. If you do that, you can't get it wrong. That's one way you can write it. However, some teachers may want you to write a single equation that could describe both of those numbers. And for this one, we can. Notice that pi over 4 and 5 pi over 4, they differ by pi, or 4 pi over 4. Because of that, we can write a single equation. We can say pi over 4 plus pi n. If you plug in 1 for n, you're going to get 5 pi over 4. So we can, instead of writing these two separate equations, we can write one equation that will describe all the answers where tangent x is equal to 1. So that's it for that equation. Let's try our next problem. So let's say if we have 3 tan cube, let's say it's equal to tan x. How would you solve that problem? Now what you don't want to do, you don't want to divide by tangent x. Instead, you want to subtract tan x from both sides. So 3 tan x minus tan x. 3 tangent cube x. If you divide both sides by tangent, you're going to lose an answer. Instead, what you want to do is factor out tangent x. 3 tan cubed divided by tan is 3 tan squared. And negative tangent x divided by tan is negative 1. Alright, so this is what we have. After you factor it, separate it into two equations. Tan x is equal to 0, and 3 tan squared x minus 1 is equal to 0. So at what angles is tangent 0? Tangent is 0 at 0 and pi. If you type tangent of pi, you get 0. If you type in tangent of 0, you get 0. For the other one, we need to add 1 to both sides, and then divide by 3. So tan squared is 1/3. So if we take the square root of both sides, the square root of 1 is 1. And so we have 1 over root 3. If we rationalize it, if we multiply top and bottom by radical 3, tangent x, therefore, is equal to plus or minus root 3 over 3. Now for this answer, you can't use a 30, 60, 90 triangle or 45, 45, 90 triangle to get this answer, because it's not in any quadrant, it's on the x-axis. So either you know it based on a unit circle, or you can use a calculator to get one of the answers. For this one, we can use one of the triangles to figure it out.
Alright, hold on 1 minute. So, I'll watch the Brian McLogan one, then the Organic Man, then Professor Dave. Oh wait, is this one? Find all the solutions. Actually, I'm gonna watch this one. Whoops. I think this is a better one. Maybe. General solution. I don't think the general solution is what I need. be honest.
Alright, so ladies and gentlemen, when we're solving for our equations, which is going to be our next step, the main important thing is, guys, we're just going to solve this just like any other equation that we've done before. Rather than doing our, a lot of our simplifying techniques, simply what I'm going to do here is just get my cosine of x by itself, right? Because to find our values of my x, I need to get this cosine of x by itself. So what I need to do is undo the operation that's happening to it. So first thing we always undo is addition and subtraction. So I'll subtract the 1 on both sides.
Very
I
true.
get 2 cosine of x equals -1. Then I'm going to want to undo the multiplication that's happening to it. So I'm going to undo multiplication of 2 by dividing by 2. So I get cosine of x equals -1/2.
That's kind of it's almost exactly what I have for here. Cool.
Then I need to see, well, what values work for
Oh
when
wait,
x
this might actually help. No shot.
or cosine of x
No
equals
shot, dude.
-1/2. So I'll just go ahead and think
Yo,
about my
he's
unit
doing it.
circle and
He
think
pulled it
about,
out.
well, cosine of x
Holy
equals
dude.
-1/2. I know at this angle and this angle. And I think, all right, well here, that's going to be 2 pi over 3. And this angle is 4 pi over 3.
Wait, hold up, buddy.
Half
What happened
circle,
there?
and think about, well, cosine of x equals -1/2. I know at this angle and this angle.
Oh, because of the references.
And I think, all right, well here, that's going to be 2 pi over 3. And this angle is 4 pi over 3. All right, I kind of just already have everything. Memorize this angle is a -1/2, radical 3 over 2. This one is a -1/2, comma negative radical 3 over 2. Okay? And that's just for me, like I said, I just reprinted the unit circle for you. You guys, like I said, we've had a lot of practice knowing where those 2
Okay,
points
I think I'm on the right track with this. Why'd it do that? Pull out the unit circle real quick. Okay, that would be right here. It's a negative. Wait, no, it's y, it's y, it's y. That's for Kiss. Like what he was doing. Down here. To -1/2. Oh, there's another one. Should be all of them. Yep, alright. So I'm guessing from here, he does like, he makes the reference triangle. Probably. I'll let him cook it. I'll see
So
what it
you
is.
guys can obviously see that my x value for these 2 points is at -1/2.
Oh wait, I drew it wrong. Or did I? No, I think I should do it right.
That's the only 2 values that we see. So I can say now that x equals 2 pi over 3 and x equals 4 pi over 3.
The 2 solutions. That's why you gotta find all the solutions. I see, I see. This is 210. Or in this case, 7 pi over 6. Yup. And then just keep going to here. It's 11 pi over 6. So there should be the two answers to x. Can I check these? I wonder. Try. Okay, that did not give me what I wanted. Maybe because I'm in radian? Hopefully. Or I was in degree? 20. Wait, no, that's, what is that? Hey, I got it. Nice. Check the other one. Let's go, man. Divided by 6. I'm very slow at typing. Hold on. Yeah, easy, dude. So easy. We won't talk about how it took me like an hour to do.
Does everybody got that? Does everybody understand, really?
Oh, we understand, Brian.
It is cool. Yeah, because both of these values, my cosine, the x value is -1/2. But remember, as we keep on going around, we have coterminal angles, right? Remember I showed you with the graph? We have our coterminal angles that it's just not 2 pi over 3, it's also all the multiples of 2 pi over 3. So I need to add 2 pi n.
Oh, that's so true, actually. I guess n just stands for however many rotations or whatever. Holy, that's smart. What? New shot.
2 pi n.
Oh wait, 2 pi n.
Okay? We're also going to add all the multiples of that answer as well. Or
That
also,
is crazy.
any coterminal angle of 4 pi over 3 is also going to produce you a cosine of x, or cosine.
Holy, dude. What a lifesaver, honestly. That's crazy. So that's done, right? It said solve, isolate, reference angle. Yup. Found every solution, dude. Move on. Next one. 2 cos x equals square root of 3. Guessing I just move the 2 over real quick. This seems easy. Without my unit circle, dude. Square root of 3 over 2. It's probably first quadrant. Yup. And it's also last quadrant. Alright, easy, dude. Holy. Brian is actually the GOAT. What would we do without Brian, man? Alright. So this is 1, and this is 1. Boom. This is square root of 3 over 2 half. Square root of 3 over 2 negative half. It's a 30, 60, 90. Okay. It's also a 30. Okay. This is pi over 6 for this distance. And then if you go all the way around, it's 11 pi over 6. So it should be the 2 answers. I didn't draw the reference angles for these, so I'll do that real quick. Should be 45, maybe, no. Wait. No, it's 30, 60, 92. It's the same thing. Alright. So 2 answers should be pi over 6, 11 pi over 6 plus 2 pi n plus 2 pi n. And I'll check those too. So I forgot to change the counter. Alright. Now I'll check. Cos pi over 6. So it should give me, well, I'll have to find square root of 3 over 2 first. I have no idea what it is. Yep, same thing. Easy, dude. So easy. I'll find the same for 11 pi over 6. Easy. Alright. I'm gonna circle my answers, square them in. 57, man. That's 56 done. Easy. There was like 6 more of these, so it could go pretty wrong in a minute. Yep, 6 more. Oh yeah, okay. I can already see this going terrible. So 57 is cos 2x equals 1 over square root of 2. So cos 2x sounds like a trig identity. Pull up the list. Yes, sir. Cos square root of... I don't know if I want to change this yet, actually, but screw it. Okay. So I have that, was that the play? You know, I don't think that was the play, actually. I just made a big mess. I don't know if this is cheating, but could I do like... That feels kind of cheating. I don't know about that one. I don't know about that one. Yeah, this does not seem right. No. It said something, I think this is a double angle identity or something. Is that what it's called? Yes. So it had directions for double angle identities. Remember to double the domain when solving for a double angle. Really? Okay. That doesn't help. Photomath help? Possibly? Nope. Photomath's pretty useless for that. No double angle identities.
136.
Man.
$2.20.
Dave he's gotta help me, man.
It's Professor Dave. Let's solve trigonometric equations. 30 meters tall over adjacent
minute.
measure
This is
pi. That will also
yeah,
be
it
a
is.
solution. Therefore, the way we sine of 5/6 pi also gives 1/2. Not only that, but either of these values plus any multiple of 2 pi will also be a solution, because starting at 1/6 pi, if we go all the way around to get here again, which would be 13/6 pi,
How do you solve that? Yeah.
meaning we need to be able to look at equations with trig functions in them and solve for x. Say we have 4 sine x plus 1 equals 2 sine x plus 2. First, we need to combine like terms. So let's subtract 2 sine x as well as 1. That gives us 2 sine x equals 1.
That's easy.
Pi over 6 has a sine value of 1/2. And recall that pi over 6 has a sine value of 1/2. But the only problem is that this is not the only solution to this equation. The sine of 5/6 pi also gives 1/2. Not only that, but either of these values plus any multiple the way pi and conform it to the as algebraic equations of x equals quarter pi.
Oh, wait.
We located when or even in calculating the trig functions. Say we want to solve tangent 3x equals 1. Well, what angle gives us a tangent of 1? That would be quarter pi, because root 2 over 2 divided by root 2 over 2 gives us 1.
Wait, 7?
Gives us a tangent of 1.
What angle gives a tangent value of 1?
That over 2.
Yeah. Wait, oh, I think I understand inverse now. Maybe. Try something. So the original was like tan whatever equals 1. Then use inverse. Say, okay, well, what value gives me that? So it gives him pi over 4. So then that would be the answer if there wasn't a 3, right? Or something like that.
Gives us 1. That means that 3x equals quarter pi. But is it just quarter pi?
3x equals quarter pi.
If we go to the other side, negative root 2 over 2 divided by negative root 2 over 2 also gives us 1 for the tangent. So 3x fourths pi works as well. That means that 3x equals quarter pi plus n pi. Now to solve for x, we divide both sides by 3.
Oh, so it's like
that
the same
leaves
thing,
us with pi over 12 plus n pi over 3. Trigonometric equations get much more complicated than this. We can even
we don't need to go there. So that's easy then. Wait, that's so easy.
see that.
Alright. So pull up the unit circle. So you straight up ignore the 2. until the end. Bring up the circle again. Wait, that's not even on the... It's not on the circle, man. Can I do what he did? And just like... Is that possible? I'm bringing up the calculator. Let's try it now. I want to change. I want to be able to find like the radian of this. Oh man, I erased all of it. How to change form of number to radian. On TI-84. I don't know if this is what I want.
Mode. Access the
Maybe actually. Wait, it's cos, not sine. Okay, then we say like fraction. No. Divide by pi. Fraction. What? Huh? What even is this?
Pi works as well. That means that 3x equals quarter pi plus n pi. Now to solve for x, we divide both sides by 3. That leaves us with pi over 12 plus n pi over 3. Trigonometric equations get much more root 2 trig function.
Rewatch this.
Say we want to solve tangent 3x equals 1. Well, what angle gives us a tangent of 1? That would be quarter pi, because root 2 over 2 divided by root 2 over 2 gives us 1. That means that 3x equals quarter pi. But is it just quarter pi? If we go to the other side, quarter pi. Complicated. Solve tangent 3x equals 1. Well, what angle gives us a tangent of 1?
Okay, so this is finding the angle. I'm still trying to figure out inverses. That's why I'm having trouble. And it gave me this number. I don't know how to make this the form I want it to be. So I'm just gonna have to guess. Maybe. What the? Man, what? Oh wait. Crap, I gotta redo it now. I think that's it. That is it, dude. So the answer is pi over 4 for what angle this is. So Nothing more left to do, I guess. So what are all the pi over 4s in the x? Or wait, no, that's not how you do it. There's only one pi over 4 and like, it's 45 degrees, obviously. Wait, I'm getting ahead of myself. Let's see what he does.
That would be quarter pi, because root 2 over 2 divided by root 2 over 2 gives us 1. That means that 3x equals
3x. So for me, 2x would equal quarter pi.
equals quarter pi. But is it just quarter pi? If we go to the other side, negative root 2 over 2 divided by negative root 2 over 2 also gives us 1 for the tangent. So 5/4 pi works as well. That means that 3x equals quarter pi plus n.
But I gotta find the
pi. Now to solve for x equals 2 divided by negative root 2 over 2 also gives us 1 for the tangent. So 5/4 pi works.
Oh, okay. So it'd also be 2x equals 5 pi over 4. Or no. That's not it. I gotta draw the unit circle. So the first one that we found by using the inverse is this. And the cos is square root of 2 over 2. And this doesn't really matter. And the cos is also square root of 2 over 2 down here. So those are the two answers. And that's 45, 45, 90. From here to here is 45 degrees, or no, I put pi over 4, then all the way around. Here is 7 pi over 4. So that's my answer for the other one. Too easy, man. And then plus 2 pi n. Holy, was that it? And then
as
You
well.
solve for x or something?
That means that 3x equals quarter pi plus n pi. Now to solve for x, we divide both sides by 3. That leaves us with pi over 12 plus
Wait, what? Yeah.
5/4 pi works as well. That means that 3x equals quarter pi plus n pi. Now to solve for x, we divide both sides by 3. That leaves us with pi over 12.
Alright, so I gotta do both. Should be 8, actually. I might be on something, but this is what I'm getting.
Plus n pi over 3. Trigonometric equations get much more complicated than this. We can even see them in quadratic form. Take something like 3 well. That means that 3x equals quarter pi plus n pi. Now to solve for x, we divide both sides by 3. That
I love trigonometric equations and trigonometric graphs. Check with the doctor, you're not okay. There's 6?
it may look different.
How'd he get what? Huh? Within 0 to 2 pi. Okay, that makes what? Okay, I probably got this wrong, but that's the best I'm gonna be able to do right now. So that's a W for me. W. 57 done. I wonder, can I just... Is that possible? Because that would be pretty cool. I think it is. I think this is... I think this is pi over 4. Again. Yeah. That's if you're allowed the square root cancel out the sine squared. So hopefully you are. Because this is what I'm going with. So one of the answers is pi over 4. As a sine, whip out the unit circle. So we're looking for square root 2 over 2 for sine this time. Positive. Just in quadrant 2. So from here to here we know it's pi over 4. From all the way over this one it's 3 pi over 4. To be 45 again. Write it down here, x equals pi over 4, x equals 3 pi over 4 plus 2 pi n. Is that it? I think that's it. If I did it right, it's easier than the last one. I don't think I even did the last one right. I don't have an answer key, by the way, so. Sadly. Another one of the double angles.
It's Professor Dave. Let's solve trigonometric equations.
He knows a lot about all kinds of stuff. Professor Dave explains.
There are lots of problems we can solve using trigonometry, so let's see what some examples might be. The first thing we could do is find things like angles of elevation. Let's say that there is a building that is 30 meters tall, and it casts a shadow that is 16 meters long. What is the angle of elevation of the sun to the nearest degree? Well, we can set up a diagram and we quickly see that we have a triangle with both legs of known length. Which trig function do we know that relates the sides to this angle? That would be tangent, which is equal to opposite over adjacent. In this case, tangent theta equals 30 over 16, or 15 over 8. To solve for theta, we just need to find the inverse tangent of 15 over 8. We can plug that into our calculators, making sure we are in degree mode, and we should get just a hair under 62 degrees. We can do all kinds of useful things of this nature using trig functions. If we know how far away some building is, we can instantly know how tall it is just by measuring the angle of elevation required for your line of sight to coincide with the top of the building. If this distance is 100 meters and this angle is 55.3 degrees, then we can take the tangent of the angle, which will be equal to this height over 100, then multiply by 100, and we get around 144 meters. So these are indeed powerful techniques. But beyond this, we need to be able to solve trigonometric equations, meaning we need to be able to look at equations with trig functions in them and solve for x. Say we have 4 sine x plus 1 equals 2 sine x plus 2. First, we need to combine like terms, so let's subtract 2 sine x as well as 1. That gives us 2 sine x equals 1. Divide by 2, and sine x equals 1/2. Now to solve for x, we can definitely take the inverse sine of 1/2, or we can picture the unit circle and recall that pi over 6 has a sine value of 1/2. But the only problem is that this is not the only solution to this equation. The sine of 5/6 pi also gives 1/2. Not only that, but either of these values plus any multiple of 2 pi will also be a solution, because starting at 1/6 pi, if we go all the way around to get here again, which would be 13/6 pi, that will also be a solution. Therefore, the way we express this solution will be 1/6 pi plus 2n pi, and 5/6 pi plus 2n pi. With these, n can be any integer, so if it's 1, this is 2 pi. If it's 2, we get 4 pi. Whatever it is, it represents some number of times going around the unit circle to get back to the same spot, and therefore another solution to the equation. In this way, just as algebraic equations often have 0, 1, or multiple solutions, trigonometric equations often have multiple or even infinitely many solutions. Things get a little more complicated when we start manipulating the trig functions. Say we want to solve tangent 3x equals 1. Well, what angle gives us a tangent of 1? That would be quarter pi, because root 2 over 2 divided by root 2 over 2 gives us 1. That means that 3x equals quarter pi. But is it just quarter pi? If we go to the other side, negative root 2 over 2 divided by negative root 2 over 2 also gives us 1 for the tangent. So 5/4 pi works as well. That means that 3x equals quarter pi plus n pi. Now to solve for x, we divide both sides by 3. That leaves us with pi over 12 plus n pi over 3. Trigonometric equations get much more complicated than this. We can even see them in quadratic form. Take something like 2 cosine squared x minus 3 cosine x plus 1 equals 0. And we are just looking for answers in the interval from 0 to 2 pi. It may look different than your typical polynomial, but we can factor this into binomials just like we normally would. We know we will need 2 cosine x here and cosine x here. Then from there, the factors of 1 are either 1 and 1 or negative 1 and negative 1. Since this cosine term is negative, let's try the negatives, and that does indeed work out, since we get minus 1 cosine here and minus 2 cosine there. Now, as we know, each of these binomials can be set equal to 0, giving us 2 cosine x equals 1, or cosine x equals 1/2, and then cosine x equals 1. Well, where does cosine equal 1/2? That would be at 1/3 pi and 5/3 pi. Where does cosine equal 1? At 0. So the solutions are 0, 1/3 pi, and 5/3 pi. There are other situations where we will have to factor in a different way. Take sine x plus 2 sine x cosine x, solving for the interval from 0 to 2 pi. These two terms have sine x in common, so let's factor it out. That leaves us with sine x times the quantity 1 plus 2 cosine x. Now, if sine x is 0, this whole side is 0. So 0 and pi are solutions, because the sine of 0 and the sine of pi both equal 0. Then for this one, 2 cosine x equals negative 1, and cosine x equals negative 1/2. That means that 2/3 pi and 4/3 pi are also solutions. Other strategies involve using trigonometric identities. If we have an expression with sine squared terms and cosine squared terms, we can change one of them to the other using this identity. There are too many identities to do examples for each, and as we have already learned the identities, we can just remind ourselves that all of these strategies are at our disposal. I think we get the idea, so let's check comprehension. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.
All right, so ladies and gentlemen, when we're solving for our equations, which is going to be our next step, the main important thing is, guys, we're just going to solve this just like any other equation that we've done before. Rather than doing our, a lot of our simplifying techniques, simply what I'm going to do here is just get my cosine of x by itself, right? Because to find our values of my x, I need to get this cosine of x by itself. So what I need to do is undo the operation that's happening to it. So first thing we always undo is addition and subtraction. So I'll subtract the 1 on both sides. I get 2 cosine of x equals -1. Then I'm going to want to undo the multiplication that's happened to it. So I'm going to undo multiplication of 2 by dividing by 2. So I get cosine of x equals -1/2. Then I need to see, well, what values work for when x equal, or cosine of x equals -1/2. So I'll just go ahead and think about my unit circle and think about, well, cosine of x equals -1/2. I know at this angle and this angle. And I think, all right, well here, that's going to be 2 pi over 3. And this angle is 4 pi over 3. All right, I kind of just already have everything. Memorize this angle is a -1/2. Radical 3 over 2.
We're back.
This one
for
is
one more.
-1/2, comma negative
One more
radical 3 over 2. Okay. And that's just me. Like I said, I just reprinted the unit circle for you.
That's 58. Another one of these, okay. I see. Wait, is that negative? Yeah. Calculator. Okay, what is that in unit circle? Let's see. Try pi over 3. Yup. It's negative. So. Draw the circle. That is an oval. What is that? Alright. So where is square root of 3 over 2? Negative. Oh wait. Wait, that's not even what I'm trying to find. What? Pi over 3. Oh, okay, so since it's negative, it would normally be like here. Alright. Which is half square root of 3 over 2. That's for positive. But you do the opposite this way. So I can get rid of this. And it gives half negative square root of 3 over 2, which is... I didn't even have to do the inverse, it was right here. I could just use it. It's fun. Alright, there should be the two answers. Find the references. It's 45, I think. No, this is 60 from here to here. Yeah, 30, 60, 90. Sine 2x equals that's 4 pi over 3. Keep going, and that's 5 pi over 3. So those are my two answers. Divide, wait, do I divide by 2? I think I did on the others. Yeah, I do. I don't need the sign here, that's why I was confused. Divide by 2. X equals 4 pi over 6 or 2 pi over 3. Then for this, 10 pi over, wait no, 5 pi over 6. And that doesn't simplify. So I think the final answers are x equals 2 pi over 3 plus 2 pi n, and x equals 5 pi over 6 plus 2 pi n. I'll do one more. That's 59. Next one. It's kind of complicated. So first thing I want to do is add 1 to both sides. Divide by 2. I don't even know if I might be like way off. Plot metric identities. this one. I don't know. This is weird. I think I butchered this. I really doubt this is right. I might have another idea. What's this? Okay, I'm gonna redo this whole thing. So what if I divide the two? Wait. Okay, divide the two, whatever. Cos squared x minus 1. It's negative sine squared x, right? Yeah. Minus cos x. Oops. No, okay, this is wrong too. I don't know. I have no idea what you do here. This is not making any sense. Alright, I think I'm gonna end it. I'll figure this out some other time.